All right. So, what did you guys? I guess while I'm getting ready, what did you guys think of week one? Did it go okay? Um, Hoping it all worked out pretty good.
I thought it was pretty easygoing, personally.
Oh, perfect. Yeah, and I think you'll find it to be this book moves at a uh pretty good pace for beginners. So I think it'll be pretty good.
You mind if I ask you just a quick question before we
Sure.
start?
Yep.
So I typically do better in classes if I understand what I need to be doing before the due dates are actually there. If I look at a due date, I'm usually doing it 4 or 5 hours we before it's due. What kinds of things should we be doing before this Tuesday meeting? Like Monday, Tuesday, what should we be trying to get ahead on, and throughout the week as well?
So what I think would be the ideal schedule is Monday. Just review the week, kind of see what you're studying, and then start on the reading, um, if possible. And then then Tuesday comes around, we're gonna do this, and this is kind of just supplementary.
Hmm.
I hope it helps. Obviously, I don't think it's required. Um, and then I would hope that after today, you would start to really look at specifically the paper and start getting some ideas. Because ideally, what the paper is going to do, I would treat it like a research project every week. Just a little mini research project
Okay.
where you kind of want to look at it, and then as you're doing your reading, think of ways that you could answer that prompt and things that you could do actually in SQL to provide some evidence. And I'll actually go through a little bit of that this week, um, a little bit better since it's not week one and we've got all the jitters out, hopefully.
Okay.
So that's kind of what I would do. And then as you work through the week, and that's why I really like this format, because I actually had the same format. I said this last week for my graduate program, and I liked it because it gave me the freedom to kind of work along with the material. Because I would look at whatever paper I had to write. And then as I would go through the book, I guess you could say I almost wrote the paper as I went through the material. Sometimes, it'd go vice versa either way. Um, but and you can choose to do all the reading and then just write the paper, completely up to you.
Okay.
But I think ideally that's what I would do. And someone actually asked on the discussion board this week, kind of what we're looking for. And most submissions for week one were phenomenal. I would almost say all of them were phenomenal. I mean, but really what I'm looking for, I mean, I'm not going to dock either way. But I think what makes a good paper, and I think what will be the best learning experience is if you have some sort of supporting evidence in your document. So write your few paragraphs, but then add some screenshots. Because ideally that paper is just driving your experience when you're practicing this yourself, which I'll go over quite a bit today. Can you guys see my screen?
Yeah.
Okay, for some reason it doesn't have a little border around it, so I was just wondering. But does that answer your question a little bit?
Yeah. Thank you so much. That really
Yeah,
does.
no problem. And I'm actually, my plan was today is to actually kind of treat this like as if I was going to mini go through the paper, because really I think um, the the paper is kind of going to drive. Like I said, and I think I said this before, I would do the paper before I even did the quiz and the other two quizzes. I can't remember off the exercise.
Yeah.
Um, because the exercise, if you notice, is actually some SQL. And keep in mind, you get 3 opportunities, but it's the average of them. So you obviously want to do well the first time, even. So I would do the paper and practice, because the book is going to give some examples. Um, and I guess I would just practice a little bit of what you're doing. And like, again, I keep going back to my graduate program, but the best way for me to learn is to get my hands dirty on it. And so I would learn something, and then I would try to do it. I would try to replicate it, and or maybe take a little spin off of it. And that's the only way for me to really I guess, consume, not only consume the information, but retain it. And I know everyone's a little different, but it seemed to work well for me. And I think that's kind of their goal with these papers is use it as like your, to guide your practice in essence. And then that way, hopefully the exercise and quiz are a little bit easier because you've not only gone through it, but you practiced it and reiterated it in your own words, which is, I think, has been proven to be a big part of learning. So,
Yeah. Awesome. Thank you so much.
yep. Great question. So real quick before we go ahead.
Oh, sorry. Can I ask one more question while
Yep.
we're talking about this? So as we finished chapter 3, there were exercises 1 through 4. Are we supposed to do those exercises as part of the reading?
Yes. So I would do the exercises as part of the reading, and it is the paper there. They have the exercises. I would kind of say use those exercises as a prep for your paper, if that makes sense. Let's take a look at this week. Actually, let me get there.
And my other question was, I'm sure different terms kind of mean the same thing. It's just saying it different ways. And in this week's, it says testing topics using equality comparison operators and non-equality comparison operators. When they say equality, what are they referring to and non-equality?
We're going to talk about that here in just a minute. So
thank you.
Yeah, so we were going to cover that because today is going to be all about select statements. As you know from like the weekly stuff, we're going to talk a lot about select statements, and really, to be honest with you, I think that this I'm still on the week 3 paper. The week 2 paper is this on equality statements is really, I think, supposed to be in week 3, but we're going to cover it right now. And just to be upfront with you, like I'm pretty lenient grading the papers. I actually just really like to see what you guys have to say. And I mean, I will correct any misinterpretations or anything like that. To me, this is a learning experience. And it's okay to be wrong, and it's okay to, to try to work your way through it. And I completely understand that. So don't fret too much about being so accurate all the time. It's more about learning, and that's why I like the papers, is because really you get the chance to back up your stuff, and even if it's inaccurate, I can correct you and we can keep moving forward, and it'll be a learning experience. So I wouldn't be too worried about it. Like even the grammar, I think I said this last week. I'm going to treat it like a business, or like like business correspondence. Like I don't really care about grammatical errors. It's not an English class, but I just need it to look professional and be professional. So I'm going to treat it the same way as I like with the other stuff. I mean, obviously it needs to be on topic and all that, but like I said, week 1 submissions were great. So if you just do that same format, don't fret about it and just have a good time with it. Everyone's been doing great. So anyways, the instructions. So let's see. I lost complete track of where we were. Do you know what we were looking at? I lost track.
I
have a question.
Assignments and how we apply. We're just going to do the assignments, and as we're doing them, use them as our examples for our case study. If I'm understanding correctly.
Yes, that is correct. That's right. So let me go here, and in week 3, right? Or week 2? Does week 2 have the exercise? Yeah, right here. Oh wait, that's just the quiz. Where are the assignments you're talking about? Or are they in week 3?
They're in the book, I believe.
Oh, gotcha. So, I have the book here somewhere. And someone else had a question. While I'm pulling the book up, if you want to ask your question.
I just wanted to know, like last week, the instructions said that we were supposed to learn how to use the CLI. Does it matter during the course if we use the CLI or the workbench?
No, you can use whatever tool you want. I'm not picky about that at all. So whatever tool you want to use, go ahead and use it, and And you can even, like when I say like use examples, yeah, you can use whatever tool you want. And I don't even care if you just share code snippets. Like we're gonna start getting more into like some code here, and so I think as long as you're sharing some of your work, that's good enough. And sorry, I'm gonna hurry and get this book, so we can see some of those examples.
I have
Um,
a little related question to that too.
uh-huh.
I've been trying to use the CLI, that came with the MySQL installation, and I'm not having any luck with it.
Okay, yeah, we'll go over that a little too, because I'll probably use that myself. Let's see, I cannot find a copy of that book anymore.
On O'Reilly,
Yeah, I'm trying. Well, I have a PDF version of it somewhere. Problem is, I have a lot of PDF books. Oh, Learning SQL, right? Huh. I know I had it downloaded on here somewhere. Anyways, also.
I put the link in the chat for you if you
Oh,
want.
perfect. Yeah, I'll circle back around to that because I know I have it here somewhere. So I'll circle back around to that, see if I can get in there. But I guess in prep work, because I actually don't have MySQL installed, and I know I talked about this last week, so I was just gonna install it here real quick in case there's anyone on Linux that needs to see it. So while that's getting installed,
That's a little quicker than it goes through in Windows.
yep. Yeah, and the nice part is it's all ready to go. The only thing I'll have to do is set up this Aquila database, which I have ready as well. Which is what I wanted to show you, because one thing that we haven't covered yet that actually some people kind of hit on in their week 1 papers in their comparison between the GUI and the command line is how to execute scripts. So I'm going to cover that here in just a second because I'm going to have to run some of those scripts enabled to do this. So MySQL, we need the workbench. I don't have it yet. So let's see what the package name is called. MySQL workbench. Apparently I don't have it. Huh. Usually that's a lot easier. We'll just get it here real quick.
which Linux flavor are you using?
I use Pop! OS, which is a Ubuntu variant. So this one right here will work good. Usually usually you can just apt install, but we'll just install it this way. Oh, well, maybe they quit making it for us. Let's try the other one. Your page isn't very friendly to me. There we go. Looks like that one's going to take. There we go. All right. So now we have that, and we have MySQL Workbench. All right, so I installed MySQL, and I can connect to that just like normal. I'm going to do MySQL-u root-p, so on and so forth. But so let's do show databases. Let's see what's in there. So right now I don't have the Sequila database. So what I'm going to do is I'm actually going to create that really fast. So we can run the scripts, which I'm already at. So let me just exit out of here. So if I look and see where I'm at, we can see that I have these two .SQL files. So .SQL files are the SQL scripts that we're going to run. And just so you know, we're going to get some terms here. A schema is another word for database. And it kind of came about because within a database, you can have multiple schemas, which are kind of like databases within a database. So schema is what a lot of people call like a specific database inside of a database. So if you see the word schema, you can kind of use it synonymously with database. And a lot of people do this. You might come across this pretty frequently where you have one script or one set of code that builds your tables or your structures. And then the other set of code fills that because sometimes you want to fill it with your own data or they give you the opportunity. So I'm going to run this first one. So I'm going to do, let's jump back into MySQL. And I'm going to say source Sequila schema.sql. And that's how we execute that code. So now if I say show databases, we now see that I have a Sequila database. So I'm going to say use Sequila, and I'm going to say show tables. And we can see a bunch of tables in here, just like you guys have. But if I select something from that, like let's select everything from actor, it's an empty set. And it would be an empty set for everything because there's no data within these tables. So to get the data, I just run the Sequila data.sql script, and it will insert all those rows. So if I do show tables again here, we still see all of the same tables, but now if I do select everything from actor, we're going to get results. So that's how we execute scripts in command line. Now I'm going to be doing a lot of my work out of MySQL Workbench just because it's easier. A lot of you guys hit on this in your week 1 paper and great comparisons, by the way. And so a lot of you said, in my experience, MySQL Workbench has just been easier as a beginner. And that is absolutely accurate. It very much is so easier. And that's why I'm going to use it just because I think it's easier for beginners. And that's why I say use whatever tool you want. And I guess just to summarize, a lot of you guys hit on this and I left comments on a lot of your papers in the same regard. Because in the prompt, it said that command line users are going to be more productive. And I think that's a true correlation. However, I don't believe it's because they use the terminal. I think it's because they're to a level of proficiency that they can use the terminal. And so it's completely okay to use MySQL Workbench because maybe you're not to the level to where you're confident to use the terminal, because many of you guys hit on this as well, where the terminal is kind of unforgiving because if you run a command like select everything from actor, if you do a typo in that, like let's say we select from actor, let's say we forget to put the asterisk there, you get that error and you have to retype it. Now that's a small one, so it's easy to retype, but let's say it's really long. And I'll be honest, when I write my big queries, I don't use big giant. I use a code editor because when I'm writing my big giant SQL scripts, I want to edit them in bulk and I want to copy and paste better and all that kind of stuff. So just know that it's completely fine to use a workbench, and that's what we're going to be doing. So the first thing I need to do is I need to build me a user here on my computer that that can log in. So let's create, let's do grant all privileges on, you guys did this last week. Well, let's just make it from everywhere. Let's make my password School Rocks. Let's see, what did I do here? Oh, I need to, let's do this. Create user. School Rocks. There we go. And let's try our grant again. And again, this is where all privileges. I always misspell privileges for some reason. So I'm going to make myself a super user here, which is not entirely the safest, but we're going to do it just so we don't run into any issues. There we go. All right. So now I should be able to do MySQL-U and do School Rocks. There we go. All right, so we're all set up. I'm going to go ahead and make my connection here, and I'm going to say we're going to just call it CIT225. Username is not root, it is my name. And we're going to test this connection here, make sure it works. And it looks like we're connected. So we're going to go ahead and save, and we're connected. All right, so let's, now that we're all up to speed, and I'll do a little bit of command line, a little bit of GUI at times, just so you can see a little bit of both. Most of the time, though, we're going to be editing some SQL, especially now that we're here in week 2, because we're going to talk a lot about the select list, the select clause, I should say, and we're gonna jump right into the different components of the select list, what they do, and then how we're going to use that to pull some data out of our stuff. And we're even going to jump into a little bit of joins to learn how we can connect some data, because that's kind of the key to the database. That's what makes it so nice. So what we're going to do here, and like I said, I'm going to try and use the paper as a guide to what we're doing here. So I'm actually just going to pull up this here in the PowerPoint as well, because there's some good information here, and I think it's really summarized. So let's take a look at the paper. And I'm in preparation and reading. Let's go to the paper. All right, so our papers, we had a profitable first week at our new company, which is always good. And we know how to use the command line interface tool, and we're going to learn how to write some SQL. And I think that's the key. Knowing how to use command line interface is really the key. Can you do it? Because like I said, I often use the GUI myself. In fact, I use a tool called dbeaver, which is really nice to connect to. I connect to multiple databases through here. So like we can actually see some here where, you know, I do some work. I have a lot of databases, so I connect to many of them. And this is the tool that I use most of the time, but I have to often get on the server and do it through command line. Whether that's because that's the only way, as you saw here, I have to create my users. Obviously, you have to do that first. So I think, like I said before, what makes you more productive is that you know how, not that you have to use it all the time. Because I just think that there comes a certain level of expertise when you can do it with a terminal. So our boss gave us a new assignment, and this week we're going to learn how to explain the various clauses in a select statement and the nature of column and table aliases. And they use SQL, and that's a typo. And the SQL uses column and table aliases. We should cover the basics of grouping and ordering result sets, which we're going to do. And then the paper is that we really cover a report that clearly explains what you learned about the various comparison operators in the where clause, which we'll cover here in just a minute. So we kind of know what we're looking at, right? So we know the paper's about the where clause, but we know the main focus of this is select statements. We got to know what every little piece of it does, and be able to explain that in our own words. So if we take a look at the PowerPoint, this I think is the best explanation. And we're going to talk a lot about ordering here too. So the first part is the actual select clause. And what it does is it tells us what we want to show. So for example, if I take a look at actor table, let's take a look at actor. So if I take a look at what's in the actor table, and can you guys read this okay? Text big enough? Real quick.
Looks good to me.
Perfect. All right. So if we take a look at the actor table, we can see that there's an actor ID, a first name, and a last name, and then the last update. So the first part, and just so you know, the SQL was written in such a way, it was designed in such a way, it was actually meant for business people, so that because the makers thought that, hey, if we make this language easy, they won't need to hire like computer people to do it. Well, here we are years and years later where, you know, business people, I think their proficiency has only digressed because we still have jobs. Thank goodness. But anyways, they made it easy. So the first thing that you start with pretty much on any project is, what do I want to get out of this? What do I want to see? Now, it doesn't matter if you're writing it for a report. Like, let's say you're an analyst and you're trying to build some graphs, or whether you're writing it for the back end of an API as a developer. The main thing is you say, okay, what data do I need to see? And that's the select list. So if we want to see the first name only, we can say select first name from actor, and we only get the first name. So, but if we want to see like first and last name, then we can add that to our select list. And so the select list just simply shows what we want to see. It just adds columns. So whatever columns we put in that list, that's what we're going to get out of it. So the select list. Now, there's the basic query is select from. So those are the two required ones. And the from just identifies where we're pulling our data from, right? It kind of makes sense. Where are we getting the data from? And so in this case, we were getting the first and last name from actor, because there could very well be another table that has a first and last name. Let's see if we can find one. So if we take a look and we show tables, let's take a look at customer. So there's our first and last name there as well. So when we select first and last name and last name, we have to specify where we want to pull that data from. And in this case, we can choose which table. So in this case, let's take a look at customer, and there's our first names from customer versus actor. So pretty straightforward. Now, the next view is where we start to get a little different. So most of the time, we don't want to select everything. We don't want all the data. And when I say select everything, we can choose what columns we want to select, but it's going to spit out every single row in that table, right? Because we choose our columns in the select list, but we want a way to filter down actually who's in here. So let's practice one of those. And this is where I'm going to jump over the GUI just in case I make some typos. So let's say, first of all, let's use Sequila. Execute that. And let's go ahead and let's run, let's select the first name and the last name from customer, where last name is equal to Wofford. Hope I'm saying that right. So now you can see that we're still getting the first name and last name. The only difference is we only get one person returned, Virgil Wofford. And that's because I use the where clause to filter data. So the way I like to think of this is the select list chooses the columns, the where list chooses the rows. So if we want to filter down the number of rows, we use the where clause. So again, I'm going to describe, let's show tables. Let's see if we can get a better example here of some nice ones. So let's take a look at, let's take a look at store. Let's see what's in store.
Can I ask you a quick question?
Sure.
Does select always only do columns, or is there any instance where select would do row instead?
It always does columns.
Okay.
Yep. Because basically the select list is going to tell us what columns we want to see. And then the where list is where we kind of get to filter out some of our data to get the results that we wanted. So like, let's say, for example, your boss comes to you and he says, hey, I need everyone whose last name starts with a W. And most of the time they'll say, hey, I need everyone's first and last name whose last name starts with a W. And so in a case like that, we would do something like the following. So we can actually pull everyone whose last name starts with a W. And we can expand on that. Let's say, hey, you know, I'm looking for someone. I know that their last name started with a W and their first name started with a C. So then we could say where last name starts with a W and first name starts with a C. And we can go ahead and run this and we get two results, Connie and Cassandra.
Okay.
So our select list is going to show us the columns, and the where is where we're going to filter down the actual records or the rows that are returned.
Cool. Thank you.
Yep. Good questions. So now we're going to pause here and we're going to do a couple of different queries to kind of see what where we're getting at. So I'm actually going to take a look at the rental because we want to get into some numbers here. So let's describe a rental or some dates. Here we go. This is perfect. So if we take a look at the rental table, you'll notice that we have this return date here and the rental date. So we can assume here that the rental date is the day that they checked out the rental, and the return date is the date that it's supposed to come back, or the date that it is returned, I'm guessing. So let's run some queries here just to take a gander. So let's select. And I always just start with selecting everything from rental. So again, just our basic query, we can get a feel for some of this data. We can see our rental ID, the rental date, the inventory ID, the customer ID, and the return date. Now, in comparison to your Excel spreadsheets, you'll notice that a lot of this doesn't make a lot of sense. Like, so for example, our customer ID is 130 here. That doesn't mean anything to us yet. However, we do know that customer has let's describe customer here. We know that customer has a customer ID column. Now, odds are that those are connected, which in this case they are. Now, we could check to actually make sure, but in this case, we're just going to go out on a limb and say that we know they are. So what we're going to do here is, in fact, let me just show you how we can check while we're on the topic. So if I'm looking at rental and I want to know if it's connected, in the GUI here, we can actually hover over rental and hit this gear or this wrench, sorry. And when we go here, we're going to see all the columns, but the key that we're looking for is foreign keys. That's how we connect things. We're going to take a look at this foreign key, and we can see here that customer ID is connected to, so our reference table is Sakila.customer. We can see right there. So that's how we know they're connected. And so we're going to use that to tie some things together here in a minute. But we're going to stick with this with the where clause for a minute because I want to show you a couple of these comparison operators. So the first one is a simple where clause. So let's say we're looking for all the rentals that happened on a given date. So we would say something along the lines. So let's select everything from rental where the rental date is equal to, and this is where we can punch in a date. And I'm just going to, looking at that data there, I'm just going to use one of those. So 2005, May 24th. So let's just run this. And you'll notice that we get null. And that's because date formats are very particular depending on your database system. So like things like Microsoft SQL, they accept this date format, but MySQL does not because the dates are kind of weird that way. So when we're looking at dates, oftentimes you have to put it in a desired format, which in this case is 24-May-2005. Maybe. Where's my results? Is that it? Let me see if I can get my result page to come back up. There we go.
I thought you had it right the first time.
Yeah, let's take a look. It might have just not have been happy. 2005-05-24. I guess let's make sure there's dates that time. Maybe I just misread it.
Try June.
Do you have to have the time in there as well?
Oh, yep, you're right. So
Yep, hit date. Right?
yeah, so I guess another good lesson here. Because we're doing an equal comparison, it's going to default this to midnight. So it's going to look like this. We don't see that, but that's essentially what it's comparing it against. Because we don't specify a time, it just assumes that we're talking at 0 because this is actually a timestamp. So where we're using the equality operator, we can't check to see if it's specifically equal. Now we could check for a certain time. So like I could go 23:03:39. Theoretically. So I'm not typing that right.
That place is open late, huh?
Yeah. Yeah. Well, and most of the time they're probably in like UTC, depending on how you store them. Most of the time you store in either local time or UTC. Let's see, 23:03. Yeah, that should work.
Brother Crook, could we just put date in the where, right after where, and then we wouldn't have to worry about the time?
Yes, you could do this as well. You can convert that to a date and then the time does not matter because basically we're converting the timestamp to a date. So just like that, we can actually turn rental date, essentially cutting off the timestamp, even though it still shows here. And in fact, let's actually do this. Let's select the so we can see how it's comparing it. Let's select the rental date. So you can see when we use that function, the date function, you can see it cuts off that timestamp, which is why we can make this work just written out like this. Excellent point. So let's change it back here to everything. But the one I really wanted to get to, and I sent this out with the announcement is, let me see if I can find it here. These where clause operators. So we obviously covered equal to. Let's try greater. So if we want anything that's where the date of the rental date is greater than that date, we can do this. Now in dates, the later in the year we get, the higher the number. So when we talk about greater than, we're going to get everything that's after, because we want where the rental date is greater than the 24th. Now, if I change this to like the 25th, we're going to exclude the 25th and the 24th from our result set, or lower. If we were to flip this the other way, we'll get a smaller result set because it'll be what's less. So time gets older or greater as we go. So there's our greater than, less than. We can also use the greater than or equal to, less than or equal to, obviously like we normally would. Now, as you can imagine, this only works with numbers and dates, because those are sequential. So greater than, equal to. You can also do it with strings, but it doesn't quite work the way you think, because it actually does a value comparison. So with strings, oftentimes we have to use some different ones. So for example, I guess before we do that, let's get the like, and a couple others. I skipped ahead too much. So the not equals, we can say does not equal, exclamation mark equals. So we're going to find anything that's not on the 25th. Or the other one way to write that is like that. Let me see if I can make this a little bigger. Preferences. SQL editor. Fonts, there we go. Does that not let me change it? Let's change both of these. Let's make that a 14. I don't know if that actually changed it, but we will try. All right. And then let's see. So there's our not equal. So, and then our between, that's the one that I really wanted to cover. So one of the most frequent things that you'll have to do is see if a date is between a certain thing. So we could say something along the lines of where rental date is between 2005, 05, let's say the 30th, and 2005-05-31. So now we're going to get everything that's between the 30th and the 31st. And you'll notice that that's inclusive. So I ran that result. We get the 30th and the 31st. So these are kind of hints that you might, that would make good stuff for the paper. Between is inclusive. You can try a bunch of different queries and play around with it, because a lot of times it's, you might want to, I like to play little games where I'm like, okay, let me see if I can get a realistic result set. Like I want to get, the rental dates between this date and this date for whatever reason. And you can play with that. Okay, so now we're going to get into more of strings and that kind of stuff. And this also works for numbers, but strings mostly are the big ones. So let's take a look at city. Let's see what's in city. Let's describe city. And let's select everything from city. Let's actually do that over here. So let's select everything from city. Okay, yep, we've got quite a result set. So we can, the first one is the like, which we've kind of done. So let's say we want every city that starts with an L. So let's say select everything from city where city is like, and the like operator is how we can do some comparison. It's kind of like a fuzzy search, if you will. So if we want to know if something starts with a letter, we can say it's like L%, and then basically it's saying, oh, as long as it starts with a capital L, I don't care what comes after it. We can run that and we can see that that is the results. Now, let's say we want to slim this down even more and we want to say, oh, we want ones that start with LI. Then we can, say like LI. And then we only get those ones. Now, let's say we want to take this one further and we want it to where it's LI anything, but it ends with a G. Now you'll notice that we get only one Leo, and I'm going to butcher that name, Liao Cheng. So you can use that wild card to kind of put where you are okay with having anything like that. And you can do regular expression there if you want. We're not quite there yet, but just, the like will search for a pattern. And then finally, we can use this in clause, and I'm sure there's probably a couple more, but these are the main ones. So let's take a look at what we have in city so I know what we want to do here. Actually, let's see if we can guess some. So we want to see everything in city where city is in, and then in this case, we give it a parentheses and we give it a list. So let's see London, Paris, New York City. Let's see if we have these three. So when we use the in clause, it's going to return them if the city is in this list. So we obviously have London, and that's actually it. But believe it or not, there's actually two Londons. But you'll notice that they're in different countries, 102 and 20. So we have two different London cities, but no Paris or New York City. So that's kind of the where clause and some of those comparison operators. But let's go back to our thing here because we want to keep talking about the select list because we've seen a few examples where we can kind of select some different stuff with the basic select from where. So we can choose what columns we want to see, where we want to get the data from, and what rows we want to see if we want to filter those down. Now, one of the big parts of the paper is that it says you should also cover the basic of grouping and ordering result sets. Now, I'm going to talk about ordering first. So I think it just makes sense because most of the time you're going to order stuff first. So let's go back to our customer. Let's select everything from customer. And let's get a look at what's in there. Now, most of the time, we want to sort things, right? We want them in a way that we can find data quickly. And you'll notice that this is in no particular order besides the customer ID. If we don't specify a ordering manually, most of the time it just sorts it by the order that it's in the table, or it does sort it by the order that it's in the table, which happens to be sequential with the primary key. So, but we want to specify a specific order. So let's select, what do we want to see? We want to see the first name, the last name, and the email from customer. And we're not going to filter it. We want them all there. And we want to order it though. We want to say, oh, let's say the boss comes to you and he wants it ordered by last name, first name, ordering, because he wants to be able to look up someone's last name and very quickly. So we're going to say order by last name. And let's just start with there. Let's run this. And we'll notice that this is in last name ordering. We go from A, B, C, D, E, F, G, and so on and so forth. But if we look within the A's, we have R first and then a D later. So we know that first name is an alphabetical, but we want it to be last name, then first name. So we want it ordered by both. So we can just add first name to this list and we can run it. And there we go. So now if we take a look, we have A, B, and let's see if we have some where there's two. So if we look at Adams, Nathaniel and Kathleen. We need some last names that are similar here. Here we go, Barnett. So we have Carol Barnett before Tracy Barnett because.
One's Barrett, sorry. Tracy Barrett.
Oh, yep, you're right. I don't know if there's are two that are the same here. Most of the time when you get these sample data sets, they try to avoid, or they try to get too creative. Like, for example, Douglas and Douglas. So let's take a look. I'm not seeing any right off the top of my head. But anyways, it would work. It would sort it by that first. Now, let's say we wanted this in reverse order, last name and first name. So by default, the order by clause assumes that you want it ascending. If you want it the other way, or if you just want to put it in there just to be sure, you can add the keyword DSC for descending, and it will flop it. So now we'll go the other way, where we start with the bottom and go up. All the way up. All right, so that is really our query clauses. Let's take a look here. All right, and you're going to read a lot about some views and some stuff like that, which I think should make pretty good sense. But I'll explain it here just a little bit. So a view is kind of like a virtual table. And in fact, I'm going to make one real quick. So let's say this is something I use frequently. You know, first name, last name, email, sorted, pretty common. Actually, let's do this. Let's have a little bit more fun. So let's say that we want to frequently get last name, first name combined to have their full name. So let's say first name and last name. We actually have, well, let's start simple. We'll start simple so we don't get too confusing. So let's run this and see what we get. All right, so now you'll notice in this first column, we're getting their first name and last name squished together, concatenated. Well, what we want to do is we want to put a space in between those, because basically what we're trying to do is get their full name there. So what we're going to do is we're going to concatenate twice because we want to add a space in between their names. So we're going to go ahead and put that there. Let's run this, see what we get again. There we go. That looks a little better. So now we get their first name and last name. Now, one thing that's really interesting about this is you'll notice that we still have this order by last name, first name. And this is a concept that's kind of hard to grasp, I think, at first. So when we select data, a lot of times we perceive that we're only dealing with the data that is output because that's all we can see. But in reality, all that data, I like to imagine that it's still all there. When we use the select list, we just choose to hide it. We choose to hide the other columns. But the last name and first name is still there. So we're still ordering by the last name, first name. So if we would take a look, you'll still notice that it's going to sort it by alphabetical last name and then by alphabetical first name, even though we have connected these two. It's still going to be there.
Is there a reason why you use concat twice instead of just using a, I don't know, like single quote, space, single quote in between first and last name?
Good question. So if we, let's,
I tried it on mine and the output is the same.
Yeah. So it just depends on the system that you're using. So a lot of mine's habitual.
I did concat on the very first one,
Oh,
but then
gotcha.
I didn't include the second one is all I did.
Yeah. So, and that's where it's kind of habitual because some database systems will their concat function takes multiple parameters, where others only let you put in 2. So we can see that the output's the same. So MySQL allows you to put in multiple parameters for the concat function. Some don't.
Okay.
And in fact, in some other systems, you can actually even pipe the results. So for example, in Oracle, and I actually don't know if this works in MySQL or not, you can actually just go like this.
And that syntax is called piping.
Yep.
Okay.
It's just a pipe concatenation. I can't remember the specific term, but I call it piping because it's a common Linux term. So,
okay.
But in this case, actually, we see that it's not giving us the proper result. So this is the only time. SQL is a very standard language, but the only time you'll see differences between MySQL and a Postgres and an Oracle and a Microsoft SQL Server is in little things like functions, and stuff like that. But the overall format is the same.
Okay.
Of the select list. So I like to tell people often that when you once you learn SQL once, switching to another database system is not hard. Most people, all they care about is that you know SQL. They don't care if it's Microsoft or any of the others. So,
okay, thank you.
Yep. And now we're going to jump into the second part of our paper, which is, or part of this paper, which is column, the nature of column and table aliases. So you'll notice here in our output that we have this, like the name of our column is concat first name space last name. And we don't want that, right? If you're going to hand this report to your boss, you want it to look nice. So we're going to give it an alias, which when we say an alias, we're going to just kind of temporarily rename it, this column. And this is a good example because I mean, we can rename any column, but a lot of times it's necessary, like in this, where it doesn't output normal unless you do. So we're going to call this full underscore name. So it's kind of consistent. So now we have our full name column and our email column. And that is an alias. And we can alias a column and we can alias a table. So I'm going to take this same exact query. And we're going to give this table an alias. So I'm going to say from customer C. Now, the only difference is when we alias a column, we put as, and then the name of the column. When we alias a table, we can just put it space and then the alias. And so I like to use the first letter or something like cust, something short, because a lot of times we're dealing with multiple tables. So for example, if we wanted to see, let's take a look, because I don't expect you to know this right now, but just so we have some context. If we take a look at rental and our inventory, okay, that one's going to take a little bit. Let's take a look at rental and customer. And you'll notice that I use the terminal a lot to describe tables, because a lot of times I like to describe them here so I can see what columns I'm dealing with while I type it over here. That way you're not jumping back and forth all the time. So that's why it's kind of nice to have both. Anyway, so what I'm going to do is I'm actually going to real quick show an example of a join, just so we can see why we would need to use table aliases. Because what I'm going to do is I'm actually going to say, okay, what customer had what rental? So let's select the first name and the last name from customer, right? So let's start off long format. So we're going to say customer dot and customer dot, because we want to know where we're getting them from. And then lastly, we want to get the rental date. So I'm going to say rental dot rental date. And we're getting that from customer. And we want to join that with rental based on the customer ID. This is where we start to connect things, because we have to connect our two tables. You equals rental.rental ID. And this is just, again, this is just to show you why we would use table aliases. So now we have some meaningful data here. We have the last name and first name of people as they rented movies. And in fact, we could even get more data, but we'll start with this. And you can see that when we start dealing with multiple tables, we have to specify where we get that data from. So for example, first and last name come from the customer table, while the rental date came from the rental table. Now you can imagine having to type out the table name, because believe it or not, you actually get to the point where you might have hundreds and hundreds of columns that you want to pull out, which is kind of crazy. And so you wouldn't want to type customer 100 times or even 20 or 30. So what we can do is we can alias that table, and we can make it a little easier. So what I'm going to do is I'm going to take and copy this. We're going to paste it here. And instead of having customer dot whatever, we're going to give customer an alias. We're going to call it C, and we're going to call rental R. So then instead of having to type out the whole word, we can just go C dot last name, C dot first name, R dot rental date. And everywhere that we had to type out the full table name, we can just use an alias. And let's run this, and we'll get the same result. These two queries are completely identical. The only difference is one saved us a lot of typing, which is pretty important, because you'll eventually get to where you have queries that are far easier to type when you don't have to use the whole table name. So queries can get to be very long, and we don't want to have to type them so much. So that's why we alias tables. So again, back to our first example here, we can alias this column as full name. And we could even change this email column. We could say email address if we wanted to. And then it would just change that column name. And that's really handy, especially when we talk about ETL. And ETL, if you're not familiar with the term, stands for extract, transform, and load. And that's probably one of the, I guess I would say, one of the most predominant jobs out there in the data sphere right now. And let me pull up a little picture here. And basically ETL is how you get information from one system to another. So a good example, BYU Idaho does this themselves, because we use Canvas, right, for our grades. Well, at the end of the term, they have to pull those grades out of Canvas and put it in their student information system, their My BYU Idaho, so that they can print transcripts and store them permanently. So they do an ETL process to get that data out. And so ETL, it's really important because a lot of times you're taking, it might be called email here, but where we want it, we need it to be email address. So in that case, we can say as, and it will come out in the format that the system expects it to. So column aliasing is really important in that regard, and table aliasing can save you a lot of keystrokes.
Make a comment.
Yep.
So when we get to later on, we're going to be saving these select statements as scripts, like the one you just showed us a minute ago. That's going to save you like storage space too.
Yep. Yeah. I mean, and granted, in today's today's sphere, as far as storage, like I have a terabyte hard drive, those characters aren't going to be much in our script, but yeah, I mean, there's lots of savings all across the board, whether it's in your Git repositories or whatever. So yep, good point. Yep, because we're just going to be typing less characters, right, in our scripts.
Yep. And if you're using it in a website and it's pulling something from the server, it'll make it load faster too because there's less characters to load.
Yep. All right, let's see where we're at here. Okay, so grouping and ordering. So I'm going to try and speed up because things have been going a little slower than I was hoping. But anyways, so what we want to do is we want to group some things. So we're going to use this query we have right down here, where we got the customer and we got their rentals, right? So right now we're selecting the rental date, but if we take a look at this, there's quite a bit of data here, and basically, wouldn't it be interesting to see how many rentals each person has had ever? Maybe we want to send a gift basket to our best customer. So that's what we're going to do, and that's grouping. So the tricky part, whenever we have data is that we want to aggregate, we want to compress these rows. So real quick, what I'm going to do is I'm going to order this result set. So let's order by C.last name and C.first name. Let's just order by both of those. Let's see if we have anyone who's now we're going to quick glance at this just because I'm curious if there is anyone. Well, there's only 46 result sets. Let's let's try it. So basically what we want to do is we want to compress a couple of these rows together. Let me see if I can find a better example actually, because I don't know if there's going to be any in there. Let's select count from customer. Oh, maybe it does work. Let's try it. So let's see what we got here. So what and that's why it's all kind of messed up. I had a typo here. This is going to give us better results. There we go. That's what we're looking for. I was going to say something doesn't add up there. So now we're actually pulling the results that we wanted, because I was saying where customer ID is equal to rental ID, which wouldn't make any sense. We want where the customer ID is the customer ID in both tables. So we can see that Raphael Abney has had multiple rentals, quite a few. And so what we want to do is, instead of seeing all the rental dates, we just want to see like his first name, last name, and a count of how many records he has. So essentially what we want to do is we want to compress all these rows together into one, and that's called aggregation. And the example I always like to use with this, because I think it holds true with students really good, is a great example of aggregation is when you take all your courses and you calculate a GPA. You can imagine that you have the course name and the percentage and the grade level and the GPA value, across your table here, and you have multiple courses. Well, if we want to combine that and just have your name and a GPA, we aggregate those values. We perform some sort of mathematical equation to aggregate that data. And so that's what we're going to do here. So we're going to not get the rental date. And instead what we're going to do is we're going to get a count of how many rentals they have. And we do that with the count function. And we're going to say count r dot, because we can just say, let's say rental ID. That really doesn't matter at this point. We can just say r dot rental ID as number of rentals. So I'm going to run this and it's going to throw an error, or in this case, it just doesn't show anything. And let's run this in the terminal so we can see here. So if we run this, and it kind of gives us a good idea what's going on. It says in aggregated query without group by. So basically what it's saying is it's like you're trying to get an aggregated query because of this count function. You're trying to aggregate the data, but you don't have a group by clause. So if we come back here and take a look at our clauses, if we look at this group by, it's used to group rows together by common column values. So we can choose how we want to group our data. And in this case, like we talked about, what we want to do is we want to see, let me fix this so it's actually right like the other ones. We want to group this based on their first and last name. So we're going to use the group by clause. And in fact, the group by clause is required for aggregation. If you have aggregation, it's not going to work unless you have a group by. So the group by comes before the order by. Order by is always the last thing you type. So we're going to group by, and there's a pretty common rule of thumb. Your aggregation, whatever comes before your aggregated column, in this case, ours is count. You just put both those in there. So we're going to group by C dot first name and C dot last name. And that's because if we take a look at this data, those are the rows that are going to be the same no matter what the other one is. So whatever rows you want to combine into one, that's the columns you put in there. So we're going to say C dot first name, C dot last name. Let's run this. And now we get the number of rentals per person. So we can see that Raphael had 21 rentals. Nathaniel Adam had 28 rentals, so on and so forth. Now, let's say we want to order this because we want to know who our best customer is. We want to see the list of best to worst, the people who have the most rentals to the worst. Now, there's one clause in here. Oh, there it is, having. So the one clause we have yet to cover is this having. And in this case, we can filter certain things based on our grouping. So basically, to have a having clause, you have to have a group by clause. And that sounds crazy because the word having, said that 3 times. But just to show you, let's say we only want to see people who have 20 rentals, or let's say 28 rentals or more. So we say having a count of r.rental ID that is greater than 28.
If you've already defined the number of rentals, could you just use that in your logic statement for having?
Yep.
Is there anything against
Oh,
using
you
that?
mean so like this, like we can say having number of like this?
Uh-huh.
No. You can use that as well.
Oh, there's nothing against that.
No, nope. Yeah,
Okay.
you can do that as well. If you use a column alias for that, you can just put the alias there and it works fine,
Okay.
which is really handy. Okay, now the one difference which I was getting to here is, let's say now that we have this where we having a number of rentals and we want to say greater than 28. Let's go back to that. So there's the equivalent. So there's our number of rentals greater with the having clause. Now let's say we want to order this by the number of rentals though. So playing off that same thing, I'm going to put number of rentals here. And now we can see that we're sorting by number of rentals, ascending, but in this case, we want to see who our best is. So we want to go from best to worst. We're going to add that descending. So now we can take a look. And old Eleanor, she's really liking her Hallmark Christmas movies because she rented 46 of them. Carl Seal had 45, so those two are pretty close. We have a tie for third place between Clara and Marcia, so on and so forth. So you can see how we can pull this data pretty nicely. So let's add our having back in so we can see what one looks like that has them all. Having a number of rentals greater than 28. So this is a query that has all of the clauses in it based on this. So, and again, this one has an inner join, which we're not quite there yet. You'll probably come across it in your book at some point quickly, but joins we're going to talk about a little later. but joins is just how we connect data. So you don't have to worry about it too much, but that's all the clauses. So the select list is going to determine what columns we see. The from clause determines where we get our data from. So in this case, we actually get it from customer and rental. The group by is, if we choose to have it, is going to aggregate rows or combine multiple rows into a fewer number of rows. Aggregation. The having clause will filter the group by. So the one clause we don't have here is a where clause. So let's say where last name, C dot last name is like, let's just say it starts with a C. There we go. Now we can see the best people whose last name starts with a C. If I was in this list, I'd probably be way up there because I really like my movies. But if we take a look at this, the where clause filters the number of rows. So just like before, we went from having a lot of people to only having people that have a last name start with C. But the group by aggregates it, and the having clause is what filters this, because it's actually, if we tried to say where, let's try doing this, where count of r.rental ID is greater than 30. You'll notice that this actually doesn't run. And it'll say invalid use of the group function. And that's because we try to have this aggregate function here. So the where clause can't filter aggregation results, but the having clause can. And the way that I kind of remember that is because the having comes after the group by, because the group by has to happen first. And then the last thing is the order by determines the order in which we sort our results. In this case, we wanted it by the number of rentals. Now, one big disclaimer is the ordering in which these run, the select statements run, is not as it reads, as far as the way the computer parses it. So when we execute this select statement, the first thing the computer does is it actually starts with the from clause. So it's going to go to the from clause and it's going to get all the data. So in this case, it gets customer table and it gets rental data. It gets everything. And then it runs the where clause. So after it pulls the customer and the rental data into memory, it filters it. So in this case, it goes through all those records in customer and it finds all the ones that start with the capital letter C. Then it does its aggregation. Group by first name, last name, having clause in there as well. The last thing then it gets the select statement, or then it does the ordering and then the select statement. So it kind of skip the select part and then go from here down as far as the order of operation, as far as the computer reads. Now, this is just an FYI for right now, just so you can kind of understand why the having clause. Why can't we just use another where clause? That's because there has to be different, because the where clause runs second. It runs before the grouping. So it couldn't possibly filter on an aggregate because it hasn't aggregated yet as of when the where clause is actually ran. So anyways, let's take a look at the paper, make sure we got what we needed here. So we talked a lot about the comparison operators, select statements, all that kind of stuff. I believe this should be enough to get going. Does this help you guys seeing some of that, catching some of the vision?
Yeah, it helps me tremendously.
Oh, perfect. Yeah,
Absolutely.
and I'm hoping here as we, because really select statements are the foundation. You can't really do anything until you know select statements, because I truly believe that anyone going into a technology career has a very high probability of having to run select statements at some point. So like even in my place of work, I'm actually the only database person in the whole organization. I'm kind of one man show. I do all the analytics. I do all the database administration and development. But my coworkers who vary from anything from network admin to sysadmins, they constantly have to write little select statements. I mean, and they don't get very complicated, but stuff like this they do quite frequently. So, for example, my friend who's my coworker who's a sysadmin, he often has to write little select statements to pull out like, okay, I want to bulk assign a setting to all these computers. So he'll write a little select statement so he can pull the CSV down, because then he can write scripts to do that or whatever. So I truly believe it's something that many people are going to have to do. So select statements, if you're going to spend time learning something, this is the time to really invest some time. Practice. I would highly recommend you play around. There's lots of little examples. In fact, W3 Schools has a lot on select statements. I'm going to real quick just pull one up. W3 Schools is a great little place to kind of play around. And you can kind of read more on here about some of the different things. And it has some little try it yourself things where it'll give you some exercises. So I would recommend, in your research for your paper, play around, try some things, kind of like what we just did here. We every little piece of it, we try like each one of the operators, kind of try it out, then see if you can get it to work the way you expect. Say like, oh, I want to find all the rentals between this time, or I think there's film. This one will be kind of fun. I want to find all the films that were released from this time to this time or within this year, stuff like that. Kind of explore, play around, and have some fun with it. Or it looks like they even have a length of the movie, so you could say like, oh, I want all the films that are longer than 2 hours, something like that. So, anyways, does anyone have any questions before we take off?
Yes, back to on the assignment, it says that equality and non-equality comparison operators. What are they referring to when they say equality and non-equality? Because that's not the verbiage we use. So I'm trying to figure out how it ties together.
Gotcha. And I'm glad you brought that up, because I said we would cover that. So equality is seeing if they're equal, and non-equality. So it's kind of just a fancy way to say like, I mean, we kind of covered them all. Let me see if I can find that little table here. So like equality operator, non-equality operator. It's just a fancy way. So I wouldn't get hung up too much on the
Okay, so that's what they're referring to.
The language. Yep. And I just call them, and technically I think it's just the formal way, because if you say an equality operator, it assumes that it's equal. So the way to lump them all together is to say both. So I just call them operators, because you can do quite a bit of stuff like, because technically like between, it's not really like equal to or non-equal to. It's a comparison, and really, and you bring up a good point that I kind of want to cover real quick. Whenever we do a where clause, it actually checks. It always equates to a true or false. Any statement will equate to a true or false as it checks each row. So like, for example, if we select everything, let's go back up to a customer example here. Like let's use this one. When we take a look at our query that has two results, let's select everything from customer here. It's going to run through each of these records, and it's going to run our filters, and it's going to check them. So, and like I said, each statement is going to equate to a true or false. So it's going to come here, first row, and it's going to say where last name is equal to or is like a W, anything. So does it start with a W? It's going to take a look. Does last name start with a W? That equates to false. So it immediately can exclude this record. Now, there's a couple different ways we could do this. We could say or, and I'm a big parentheses person because it helps me really visualize. So one trick I would like to, I guess, share is just treat it like math. So if ever I need to compare two things or perform two operations, I like to put them in parentheses so it makes sense. So if I want to say, look, your last name is a W or your last name is a C, I put those in parentheses so it checks it's either this or this. So we can run this and you'll notice that we get W's and C's. But like I said, when it runs through there, it's going to equate both of those. Let's use a simple one for now, and then we'll get bigger. So let's just say where last name is like a W. So let's just keep a simple query here and practice this one. So let's pretend we're going to run that query. We're going to pretend like we're the computer. It's going to start here, and it's just going to loop through all these results. So where last name starts with a W, false, false, true, false, 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 true. And it's only going to return the records that have a true on the where clause. Now let's complicate it just a little bit and let's add our or clause back in there. So now when it runs through, it's going to check here and it's going to say, okay, does last name start with a W? False. Or does last name start with a C? False. Both of them equate to false. That's the parentheses. So when we put the parentheses with the or, as long as one of these two statements equates to true, it's the whole value, the whole statement's true. So this one's going to be false, false, true, false, 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 true. This one would be false, true, so on and so forth. Now, if we change this to an and, now with the and, it gets a little different. We don't necessarily need the parentheses, or visually it's easier for me to see this because when we do the and, that means it has to be both. Now, in this case, we're contradicting ourselves. If we run this, we're going to get an empty result set because a word couldn't start with two characters. But if we change this to where last name is W and first name is a C, then we get results. And it would just simply go through and it would check again. So it's going to say, is last name start with a W? False. We don't even have to do the other one because it's an and. But when we get down to this W Williams, it's going to say, oh, last name starts with a W? True. And let's see, does first name start with a C? Nope. So this one's false and it doesn't get returned. So I'm glad you brought that up because that's where the equality comes in. Is it always evaluates to a true or false.
Thank you for covering that.
Yep.
I think it's just a different verbiage from what I'm used to. So
yeah, I think you'll find that a lot of the verbiage in the material is going to be very, it's going to be high level and very formal. So I wouldn't get too hung up on like little things like that because most of the time, and this was very more apparent in the previous curriculum, it was because even the book was written by the same person who wrote the curriculum, he's a genius. For lack of a better word, the guy is a super smart. But you have to, it's a very high level of reading and he's very formal and very technically accurate. And so a lot of times you would get lost in that. And so most of the time, like I would tell them to just go with your gut because most of the time when you read it, you're like, oh, I think it's this. Most of the time that's true. So, so yeah, hopefully it's doesn't come up too much, but most of the time it's true. All right. Any other questions before we go or?
Something from last week, reverse engineer. Are we going to see that later in the semester? Was that kind of just touched on at the very start?
Yep. So we will reverse engineer. In fact, we'll do it frequently because a lot of times I will actually kind of, I guess in a way, reverse engineer just a little bit myself to help you guys understand some of the stuff going on. Like, so for example, if we wanted to reverse engineer, let's see, I have a pretty good one here. So this is a little small project that I kind of started. It's a little website to help my dad manage his his cows, because he runs a ranch. So a lot of times, so I built this little thing that will help him put all of his cows into a computer. And so what's nice about the reverse engineer is that we can go to file and say new, and we're going to do a new ER diagram. Now this isn't DB where you can do the same thing at MySQL Workbench, but I'm actually going to really quickly show you this this database. And this is kind of where the reverse engineer comes in, because if you have access to a database and you don't know it, which many of you will start your first job and you'll be like, whoa, like I don't know what's going on, kind of a thing. So I can actually really quickly get you up to speed on how tables flow together based on some pretty easy stuff. So let's just do that. Let me give it a name. So when we say reverse engineer, it's really just about exploring your database and trying to figure out how everything's tied together. So in this case, you know, like we can see like, okay, what's our data structure like, and how are things tied together? And that's really where the reverse engineer comes out, because like we can see like an animal has a breed, and the breed is dependent upon the animal type, so on and so forth. We can see like, you know, we have pens and groups and all that kind of stuff. So because whenever you start like working with the database, like the first step is always exploratory. You know, try to understand how it works, because that's the one tricky part with data is you try to make assumptions, but depending on your work, sometimes you can't afford to make assumptions how data works. And so it's really important for people in the career. And I think it applies to development, IT, everywhere. The unfortunate reality is we spend a lot of time. I feel like we often are seen as proficient in many aspects because we have to understand at a very fine level things that aren't even our level of expertise, because in order for us to tell a computer how to do it, we have to understand it ourselves. So I think when we reverse engineer, we're really understanding the business logic, because believe it or not, what this graph tells us is that it actually defines, you know, if we were to clean it up, because this is kind of a hodgepodge mess.
Yeah.
It actually defines like, oh, like can more than one animal be, can an animal be in more than one pen, for example? So like, and even up to Facebook, you know, there's certain rules, and I'm sure we've all come across this where it's like, well, like, oh, it won't let me do this, or like we see it sometimes it's like, oh, you can only send this to 20 people, or so on and so forth. A lot of times many times, if not all those times, technical limitations result clear at the very fundamental layer of how the database is designed. So understanding that's crucial. And all that's decided when you design your database, which we will get to eventually, because one of the things I actually really want to have you guys do is actually kind of play around with designing your own database, which after we get there, we'll get there, because we got a couple weeks before we get there. But anyways, great question. Reverse engineer is really, I like to think of it as just exploring. And in fact, I do it a lot, because like a lot of times I'm looking for a certain value, or I want to see how are they getting this, this result. And then I can actually like look it up, because if we go to, this is a tool I use a lot. So like if I'm trying to decide like, oh, how do they do X, Y, or Z? Let me find one that's got a table here. So let's go to, we'll just do this one. Like if I want to see how are they getting this one column calculated, I can actually go to generate SQL and go to DDL, and I can actually see the table create statement for that table to kind of reverse engineer. So like I do this often to say like, okay, you know, where does this point to? Does this point to another table? Like for example, the mother ID. it just references another animal. And so then I can look that up and kind of understand how things work. But that just reminded me of something. So if we come back here to our count of rentals, right? One thing that I forgot to cover that was in the material is our views. So in the slideshow, you'll see that we have 4 types of tables. We have permanent tables, which is what we use very frequently. We have derived tables, which are rows that are returned by a subquery, which we'll talk about a little later, but just keep that in mind. Temporary tables, which are volatile, which held in memory, meaning that they're one-time use, which we will also talk about eventually. And then virtual tables, and that's kind of the big one that I want to talk about real quick. Our virtual table is a view, and views are often created. So you can imagine, so we did this to find our best customers, right? Let's see, I broke something. Let's get rid of you. I think that's probably here. There we go. So this is probably something that we might use frequently. And something that we use frequently with an aggregation, especially, like for example, a view that's probably very often created is student GPAs. Like at our schools, we use that frequently. In fact, we have views built on it. So what we can do is we can, instead of having to write this query every time, we can create a view. So I'm going to say create view. Let's call this total customer rental totals. And standard naming, you kind of put a V in front. Is one of my favorite things to do. So basically we can create this view, and it's kind of like a little table. Let's see what our error is, because it's not liking something, I don't think. Oh, okay. So apparently it worked. I think there's just something weird with it. So once we have that view created, instead of having to write the whole query, I can then select everything from the customer rental totals. And now I have that data right there for me. So we can create a view, and a view is a table, but it's a table based on a select statement. So every time we run this select statement, it actually is going to requery this for us automatically and pull that result. But the nice thing is that way you don't have to if it's something you're going to use frequently, it's already there. You don't have to do it, because then from there we can say, oh, we want to see how many total rentals Hunt has, where last name is equal to Hunt. And then we can see just Hunts. So it's nice that way, because it's already pre-made data. But that's also where your column alias comes in, because if you look, the customer rental totals actually has a column called number of rentals. In fact, let's see if we can refresh this. Refresh all. Now that we have it in here, we can see our view here, and we can actually copy our create statement just like I did in that other system, and we can actually see. So if you ever come across a view, you can actually reverse engineer that. So for example, our film list, let's see what that looks like. And that is not formatted well, but it's there. So then we can see exactly how they're pulling that data. Anyways, I have rambled on for quite some time. I hope that kind of helps solidify some things along the way. I hope you can see it just a little bit. So the one thing we didn't cover quite as well as I would have liked is a subquery. And a subquery is a query within a query. And you'll find that in the book. But I think now that you've seen a select statement, it makes more sense, because essentially it's kind of like what we just did here, right, with our view. And we made that view So it was actually kind of like it's technically permanent while it's there, but it's not a real table. But we could actually have done this where we just take the actual select statement, because like maybe you're not going to use it frequently, you just need it for this one thing. We can actually just put some parentheses in here and then put our query and run it. Let's see what we get this time. Oh, right. No, that should work. Let's see what we get. Oh, so that's where we need our alias. So we're going to call this T. There we go. So we can do the same thing just with a subquery, and that subquery, in this case, this is actually a temporary table or a subquery where we actually have our outer query here, select everything from this temporary table, because every query returns a table itself, and that's that temporary table. Does that make sense to everyone? What we just did right here, this temporary table thing?
Yes.
Okay. Yeah, so every time you run a select statement, you can kind of think of it as returning a table. Sometimes it will only return one. Sorry, I'm going to cover this one last thing, then we're going to be done. So if I, let's use our view actually. Let's select everything from customer where customer ID in select customer ID from rental. So if we wanted to see all the customer information of customers who had a rental, this would do that for us, because we're basically saying, look, get everything from customer, just like we always have, where customer ID is in a list. And whenever I work with subqueries, I like to run the subquery by itself first to see what we get. In this case, we're going to get a list of numbers or customer IDs. And so as long as that customer ID is in that list, it's going to get returned. So all these people have rented a movie. There's many ways to get that same result set, but this is one way. Another thing we can do is we can use a select statement to pull single column data. So like, let's get the first name from customer, but then let's select let's say we want to get the first name of a person and the last, let's say first and last name. We want to get the name of the person and the last time they rented a movie. So we would select the max r.rental date from rental. And really, we don't even need that. Let's just go like this so it makes sense. From rental, where, I think we're going to need it. From rental r. Where r dot customer ID is equal to customer ID group by. So we can do something like this where, let's see what we got going on here. Oh, subquery returns more than one row. Anyways, I'd have to play with it, but basically we can pull we can write subqueries to actually pull individual data itself, because sometimes you just want to select something real quick. You don't want to actually have to join the tables. Let's see.
Would using limit work on that or not?
Yeah, limit would work if we wanted to. Yeah, so that's another common practice, because we could say limit And sorry, correct me if I'm wrong. Does MySQL does it use a limit? It puts limit at the end, right? Not top.
I think so. I think it's at the end,
Okay.
if I remember correctly.
Yep. So what we can do is instead of doing a group by, we can say order by r.rental date descending limit 1. Because what this is going to do is it's going to sort all the rentals per that one person by descending order. So the top one is going to be the most recent or the oldest or the largest, and then we're going to limit it to 1. So it's going to return 1 result. So we can get the last rental per person. With this Alexa, and this is called a subquery. Just to reiterate, I forgot to cover that. So, and we're going to spend a lot of time recovering material. So if you don't quite get it now, that's fine. We're going to keep iterating over this material quite a bit. Every week we're going to add a little bit of new, but you're going to start seeing the same stuff over and over and over. So if you don't quite grasp it all the way now, no fret, because we covered a lot tonight. No doubt about it. I don't expect you to be pros at all of it right now. So, just play that, have fun, and we'll all get there. So any other questions? All right. Well, it sounds like that's good. So this, I think, will definitely get you something started on, get you some ideas for your paper. As far as the equality comparisons, we covered that earlier in the meeting. So anyways, good luck this week. If you have any questions, feel free to shoot me on Teams a note, and we'll keep plugging along.
Thanks, Brother Cook. You're a champ.
Yeah, no
Thank
problem.
you.
Thanks for being here.